All right, first up is going to be the power rule. We need this in order to solve radical equations. All right, we have the nth root of a equals b. Now, b can also be a radical, but for the time being, what happens? How do you get rid of a radical? What we're going to do is match a power to whatever this index is, okay? Matching the power to the given index of this given problem will make the radical go away. That's how you make a radical go away in equations. So what I'm going to do is I'm going to take the nth root of a equaling b, and I'm going to raise both sides to whatever the index is. So I'm going to raise both sides to a power of, in this case, n. The n and this n, along with the radical, will go away, leaving me with just a. And that equals b to the n. Why does the radical go away when you do this? Let's take a look at this. We had the nth root of a to the n equals b to the n. Remembering that a has a power of 1 on the inside, I'm going to change the inside to an exponential problem. I'm going to change it from a radical to an exponent on the inside. As you can see on the inside, I have a to the 1 over n raised to the n power. I can write our outside exponent of n as n over 1. So I now have a to the 1 over n times, again, that's what that means when they're multiplied together like this, it's multiplication. So a to the 1 over n times n over 1 just gives me a to the n over n. And as we know, the same number on top with the same number down below is 1. So we're left with a to the 1 equals b to the n, or just a equals b to the n. That's the reason why we raise both sides to a power that matches the index. Again, I want to emphasize this power rule can only be used on equations. You cannot do it whenever you feel like. If there is no equal sign, you cannot use this rule. There has to be an equal sign, and it can't just equal f of x. F of x is just a name. You have to have both sides, an equation, something on both sides, not f of x, in order to use this rule. Here are some steps for solving radical equations. Step 1, get the radical by itself on one side of the equation. Okay, steps 1 and 2, by the way, are going to be very similar, but you always want to get the radical on one side of the equation. It does not matter which side. If you have more than one radical, just get one radical by itself. Again, it does not matter which one. Step 3, this is the power rule. Raise both sides to a power that matches the index on that radical. Step 4, if a radical remains when you do the power rule, we're going to have to repeat steps 1 through 3. Again, 1 and 2 can be considered part A and part B. If there's one radical, if there are two radicals. So these are considered, in some instances, step 1, if you so wish. Step 5, solve the equation for the variable. By this point, the variable will no longer be under a radical. There is one step beyond this, so don't just think that just because you solve the equation means that you are done. There is an extra step. It is the dreaded check your solution. There are some in which you will have one solution you have to throw out. There may be some solutions which you keep. There may be a no solution. You have to do step 6. Otherwise, you're going to get solutions that may not work. We throw out solutions that do not work. Here's our first example. What we're going to do is go through the steps. I gave you the square root of x equals 5. The variable is under this radical. If we want to solve for the variable, the radical over the variable must go away. First thing you need to ask yourself is the following. Is the radical by itself? The answer is yes. It's just the square root of x on this side. All right, so this is all by itself. There's no number in front of the radical. There's no negative in front of it. I'm not adding or subtracting to the radical. This radical is completely by itself. Step 2, I'm going to skip because I was only given one radical. Step 3 is the power rule. We're going to raise both sides to a power that matches the index. The index here, again, if there is no index, the index is 2. This is a square root. Since the index is 2, I'm going to raise both sides to a power of 2. Now, when I say both sides, I mean all of the left and all of the right. The original problem is in pencil. I'm going to raise both sides to a power of 2. It must be the exact same number. Again, by doing so, the 2, the radical, and that exponent of 2 will all cancel out, leaving me with just what's underneath this radical. I just have x. That equals 5 squared. 5 squared is 5 times 5, that's 25. Again, the 2, the radical, and that 2 will cancel out. You're left with just the radicand at the inside. Step 4 says if a radical remains, blah, blah, blah. No, I don't have a radical that remains, so I'm going to skip step 4. Step 5 is to solve. Well, I already did that. So what happens when you're done solving it? You need to check your solution. Here is our original problem. Here is what x equaled when we solved it. All right, I'm going to replace x in our original problem to see if I get that answer. I replaced x with 25. What's the square root of 25? 5. 5 equals 5. That is true. 5 equals 5. That's true. So x equaling 25, what we solved for x for, is a solution to this problem. Again, we got the same number on both sides. Therefore, this is our true answer to that problem. You have to check. Don't forget step 6. Not only does it work on square roots, it can also work on any other index. In this case, my index is 3. So I have the cube root of x equals 4. Is the radical by itself? Yes. All right. There's only one radical, so I'm going to skip step 2, which deals with 2 or more radicals. All right, now it's time to use the power rule. Since the index is 3, I'm going to raise both sides, all of the left and all of the right, to a power of 3. Again, when we do this, the radical goes away. I am left with just what's underneath, the x equaling 4 cubed. 4 cubed, hopefully you know by now, is 64. So we ended up solving, this is step 5, no radical remained. So step 4 was skipped because I didn't have a radical left. I just have x equaling 64. What I'm now going to do is check this answer of x equals 64. Here's our original problem. I'm going to replace the x in our original problem with the answer we found. And the question becomes, does the cube root of 64 equal 4? Yes, that's true. Therefore, x equals 64 is a solution to our problem. This is a good answer. All right, now our index is 4. A little bit more stuff underneath the radical. Plus 5 equals 2. All right, let's go through the motions here. Since this radical is not by itself, there's a plus 5 on the outside. On the left-hand side of this problem, we're going to move the 5 over to the other side by subtracting 5. Again, we want the radical by itself before we do anything. 2 minus 5 gives us a negative 3. My radical is now by itself. I can go ahead and go with the next step. All right, so our step 1 is done. We got the radical by itself on one side. I'm going to skip step 2 because I only have one radical. So what I'm now going to do is use step 3, the power rule on both sides, to get rid of the radical. Again, you want the power to match the given index. What you do to one side, you do to the other. I'm raising all of the left to a power of 4. I'm going to raise all of the right to a power of 4. In case you want to see it. The radical goes away. I am left with the radicand, the 3x minus 1, equaling, now, negative 3 to the 4th. Anytime I raise a negative to an even power, it will become positive. If you don't believe me, negative 3 times negative 3 times negative 3 times negative 3. This gives me 81. Negative and negative is positive. This negative and this negative is positive. So I will end up with a positive 81. From here, this looks like a regular problem we've been dealing with all semester. I want to solve for x. No radical remains. So we're skipping step 4 because of the fact no radical remains. Let's simply solve this. This is step 5. In order to get 3x by itself, I'm going to add 1 to both sides. By adding 1 to both sides, I get 3x is equal to 82. To get x completely by itself, I'm going to divide both sides by 3. I end up with x equals 82 over 3. Again, we solved it. That is the end of step 5. However, we need to check the answer. It is a fraction, just deal with it. 82 over 3 needs to be checked to make sure, does it work or doesn't it work? How am I going to check my answer? I write down my original problem and what x equals, what I found x to be. What is my answer? I'm going to plug 82 over 3 in for x. First thing I'm going to do, besides write it out, I'm going to write 3 as 3 over 1 because I'm going to be having a fraction in here. And the cool part about this is that I have a 3 on top with a 3 on the bottom. So the fractions go away the majority of the time when we check. Again, the 3 over 3 is 1. I'm left with 82 over 1, or just 82, minus the 1 that's on the inside. Okay, 82 minus 1. Again, you have to work the radical first according to PEMDAS, or in this case, P's and D. 82 minus 1 is 81. The fourth root of 81 is 3 times 3 times 3 times 3. The fourth root of 81 is 3. 3 plus 5 equals 2. 8 does not equal 2. That is false. Our one answer of 82 over 3 does not work. What does that mean for our final result? I'm so glad you asked. Because the one solution that we got is false and there's no other answer, that means that there is no solution to this problem. I don't have another answer to use or to pull from. All right, one more time. I had one answer. That one answer is false. There is no other answer. Guess what? No solution. This is why we have to check our answers. All righty, excuse the mess on this one. I have the square root of 3t plus 5 plus 10 on the outside equals 0. I want to solve for the variable t. It's under a radical. Step 1, is my radical by itself? And the answer is no. I need to move the 10. So I'm going to subtract 10 on both sides. That gives me the square root of 3t plus 5 equaling negative 10. Good, the radical is by itself on one side of the problem. All right, I'm using the power rule. This should really be step 3 because officially step 2 is if I have 2 radicals and I can skip step 2. So this is now step 3. Raise both sides to a power that matches the index. My index is 2. I'm going to raise both sides to a power of 2. I squared all of the left and all of the right with a power of 2. Now we just work this out. I'm left with what's underneath this radical, 3t plus 5. Again, the radical goes away because my power matched the index. Negative 10 squared is just negative 10 times negative 10, which is a positive 100. Step 4 we can skip because I do not have a radical left. I simply am now going to do step 5, which is to solve this problem. Again, step 5, we're going to solve for t. So I'm going to subtract 5 on both sides. I have 3t equals 95. I just now need to get the t by itself, so the 3 is going to have to move. Since that's 3 times t, I'm going to divide both sides by 3. Honest, that's a 3. I know it looks like a 2, but it's because I screwed up. I'm going to divide both sides by 3. The 3's cancel out. 95 divided by 3 is just 95 over 3. That's as far as we're going to go. Step 6 says, I've got to check this answer. Oh joy, another fraction to check. Here we go with step 6. Check your answer using the original problem if possible. All right, there's my original problem. My t is 95 over 3. All right, since t is a fraction, I'm going to change 3 to a fraction as well. So I have 3 over 1 times 95 over 3. I'm only doing the 3 because they're multiplying, the 3 and the t, the 3 and the 95 over 3. The 3's cancel out, giving me just the square root of 95 plus 5. Work out 95 plus 5. That gives me the square root of 100. Work out the square root of 100 now, which is 10. 10 plus 10 equals 0. Hopefully you see that as false. But if you want to continue, you can. You get 20, and 20 does not equal 0. All right. We got a false answer for our one solution. Since our one solution does not work, and there is no other answer, our final answer to this problem will be no solution. So 95 over 3, even though that's our answer, it did not work. That is our only answer. If our only answer does not work, it's a no solution to this problem. Please remember to check your solutions. Last equation. What happens if you are given something that has an exponential notation on it? That's a good question. As we know, exponential notation like this means that this is actually a radical. So the first thing that you want to do is change it to a radical equation. There you go. Remember, that's innie, that's outie. This is my index. I have the cube root of 5x plus 2, and I put a 1 here just so you can see the 1 divided by 3. This equals negative 4. Is the radical by itself? Yes. Good to go. There's no other radical that remains, so I'm going to go to step 3, which is to use the power rule. If the index is 3, I raise both sides to a power of 3. The radical here will go away. I end up with the radicand 5x plus 2 equaling negative 64. We're on to step 5 now because there's no radical left. So we're going to solve for the variable x. I'm going to subtract 2 on both sides to get 5x by itself. I have 5x equals negative 66. What I'm going to do next is divide by 5, since this is 5 times x. Again, you do the opposite of what it's doing to the variable. Divided by 5. I divided by 5. X is negative 66 over 5. I have one answer. This one answer I need to check. Here is our original problem. This is what we found. X is negative 66 over 5. All right. From this original problem, you can leave it as exponential form, or you can change it to a radical right away. I just chose to leave it. I'm going to write the 5 as 5 over 1 because our answer was in fraction form. So the 5 over 1 times the negative 66 over 5. I can reduce those. The 5's will cancel out. I have negative 66 plus 2. That gives me negative 64. Now all of this is still raised to the 1 over 3. You can change it to radical form. What is the cube root of negative 64? Now, please understand this is an odd root. Odd roots means I can have negatives underneath there, so this is fine. It's the even roots that you cannot have a negative under the radical. The cube root of negative 64 is negative 4. This is a true statement. If you want me to work it out, it just means negative 4 equals negative 4. Since this is a true statement, I get the same thing on both sides. When I check, then our answer is right, and our answer is a solution to this problem. Hasta la pasta. I'll see you on the flip side. Oh, I did not put that. Are you freaking serious? How am I going to check?